In this screencast, we are going to focus on the basics of the distributive property, and more specifically, we're going to talk about the two forms of the distributive property and practice writing those forms to show equivalent expressions. So just to hit on that, an equivalent expression is just like a number sentence, and if you think about the word equivalent, equivalent means equal to, so they are equal to one another. They're just two different number sentences that equal the same thing. When working with the distributive property, like I said, we have two forms. We have factored form and we have expanded form. We've talked about an expanded form before, and that just means that we are kind of compressing, or expanded form means that we are stretching something out. So for example, in expanded form, you might have the problem 2 times 4 plus 2 times 3. You'll see that this is stretched out as two sets of parentheses, and they are attached or combined by addition. When looking at factored form is taking the number that they share. In this case, it would be a 2, and it's writing that 2 out front, and then rewriting 2 times 4 plus 3. So factored form is taking the number that they share and factoring or putting it out front. So like I said, we're just going to take a quick look at some rewriting of the distributive property to rewrite and find some equivalent expressions. So if you take a look at the screen, you'll see that we kind of have a T-chart. We have expanded form and factored form. You'll see that I gave you two examples, one of each form. So I want you to take a look at the first example. The first example is giving you the expanded form, and I want you to look for the common number in both sets of parentheses. I see a 2 in both sets of parentheses, so that tells me that that 2 is going to go out front in my factored form. So I'm going to have 2 times, because anytime a number is next to parentheses, it means multiplication, but if it helps you, you can write in that multiplication sign. So I'm going to have 2 times, and then in parentheses, that's where I'm going to fill in my other numbers, 3 and 4. And then all I have left is that plus sign. So in the middle of 3 and 4 is going to be my addition sign, my plus sign. The way to check is to see if your expressions are the same or equal the same number. So let's go ahead and solve the expanded form. I have 2 times 3 is 6, and 2 times 4 is 8. When I add 6 plus 8 together, I should get an answer of 14 for my expanded form. If we did this correctly, we should get 14 as well on the factored side. This side, factored form, we're going to use the order of operations to solve. So we have 3 plus 4 is 7, 2 times 7 is equal to 14. So in this case, those two expressions are equivalent. We did that correctly. Let's take a look at our factored form. And in factored form, you'll see that we have the factored 4 out front. I'm going to rewrite my two sets of parentheses, and I know that my 4 is going to go into both sets of parentheses because that's what's out front. It's what's shared among both number sentences. Then I'm going to take a look at what goes inside. So I know I have 4 times, and then I have 4 times 6, distributing or sharing the 4 to the 6. So 4 times 6, and then 4 times 2. Final step is to put that addition sign in between my sets of parentheses, and then I'm all done. I need to check my answer. 4 times 6 is 24, plus 4 times 2 is 8. So this would get us to 32. Over here, 6 plus 2 is 8. 4 times 8 is equal to 32. So once again, these are equal to one another. Taking a look at the next slide, we're going to have a factored form and an expanded form. So let's go ahead and find the expanded form for this factored form. So once again, I'm going to fill in 5. I'm sharing the 5 to the 6. So 5 times 6 plus 5 times 3. I'm going to go ahead and check 30 15, so I should get 45. 6 plus 3 is 9. 5 times 9 is equal to 45, so those check. Looking at this problem and this problem, I have 2's in common. Factor the 2 out in front, and I'll have 5 plus 7. And actually, if you want to, I'll keep it the same order. So this would actually become 2 times 7 plus 5. Go ahead and check my answers. 14 plus 10 is 24. 7 plus 5 is 12. 2 times 12 is equal to 24. I just want to, like I said, talk quickly about equivalent expressions. I mentioned these at the beginning. Equivalent expressions just mean that they are number sentences that are equal. So think of this as equal. Equal number sentences. So I have 68 times 5, and I want to think about how I could break this up to make it a little bit easier to multiply. I'm going to keep my small number as my common factor. So in both sets of parentheses, I'm going to have a 5. Now I want to think about what could I break 68 into that would make it a little bit easier to multiply. I'm going to think of a multiple of 60, multiple of 10, which would be 60. So I'm going to put a 60 here, which leaves me with 8 over here. 60 times 5, well 5 times 6 is 30. Add the 0 on the end, I get 300. 8 times 5 is 40. I would add these together, and I would get 340. Then I could, if I wanted to, rewrite this as 5 times 60 plus 8. And then I could do my multiplication problem off to the side. And you'll notice that I get 340. So what that means is that this equation is equal to this equation is equal to this equation. So all three of these are equal to one another because they are all equal to 340. So that's what we mean by equivalent expressions. So just to review distributive property, we have factored form, and we have expanded form. And those two forms should always be equal to one another, and we should be checking to make sure that that is true.